this video, we'll be going over the 2013 question number 3. Before we get started, go ahead and download the question from AP Central and try it out. This is a question where no calculator is allowed, so please remember to do all parts by hand. The first part is it gives us a question with some data. Now, on data questions, I often like to make a quick graph for myself. This is optional, but it can often help you as you're answering the questions. It'll help you to visualize what's going on. You can see what's increasing or decreasing, kind of the trend of the graph. Now, a few things to remember as we're doing one of these tabular data questions. First, you only have the data in question. You have to make assumptions about some of the intermediate points, but remember that you don't actually know the intermediate points. The question talks about hot water dripping through a coffee maker, which is filling a large cup with coffee, and we're given the points, the ounces of coffee for t minutes from 0 to 6 minutes. Okay, so the first part of the question asks us to use the data to approximate C prime of 3.5. Whenever you're using a data table to find the derivative, you're going to use slope. So you're going to take the slope of the 2 points, a point before this and a point after it, typically the two that are closest to you. So 3.5, the closest points are 3 and 4 for t equals 3 and t equals 4. So first I'm going to identify those points. There's 3, 11.2 and 4, 12.8. Those are my points. Then using the slope formula, I have y2 minus y1 over x2 minus x1. That's your old slope formula from algebra. So I put that in here, and my y values are 12.8 minus 11.2, and my x values are 4 minus 3, which gives us 1.6. Finally, notice it says show the computations and then indicate units of measure. So in our answer, we want to say what the units are. So here we're going to have ounces per minute because the y values or C of t values are ounces and the t values are minutes. If we look at the scoring for this question, this part was worth 2 points. One for your approximation, so 1.6, and a second point for the units. Now notice on the approximation, you want to show that work. Just saying 1.6, doing that in your head, could cause a loss of points here. On all the free response questions, you want to show your work. That doesn't mean that you have to show detailed work, but just show I subtracted these two numbers and divided, and this is what I got. Second point is for units. I recommend just always putting units on problems. They often will say include the units, but occasionally the rubric will have units where the question did not have a specific request for units. On part B, you're asked to is there a time when C prime of t equals 2? When you get questions like this, the question is really about existence. So whenever you come up with this type of question in your free responses, it's typically going to use one of the major theorems. Those major theorems are the intermediate value, mean value, and extreme value. And here the mean value theorem is what we would use. Now, off the top of your head, that might not pop in. You might think of another way to do this. But the mean value theorem says that the slope between the endpoints, that has to equal the derivative at some place between those endpoints. So here we're given the interval 2 to 4 for t. So if we check the slope between 2 and 4, we can see that just like before in part A, I take the slope y2 minus y1 over x2 minus x1. Plug in those numbers and I get 2 here. So we can say yes, by the mean value theorem, there is at least one time for which C prime of t equals 2. Now on the scoring here, you get 2 points. So first was calculating the slope, and again you'd have to show that work. You couldn't just say, yeah, the slope is 2 somewhere. You'd want to show how you found it, what points you used to find that. The second point is for your conclusion, that one statement, and for mentioning the mean value theorem, MVT. Whenever it says justify your answer, you're going to have to give a line in English of explaining why the math you used relates to your problem. Looking at part C, we're asked for a midpoint Riemann sum. So first, if I look at this equation they've given us, it's not just an integral, it's 1 over 6 integral from 0 to 6 of c of t. So not only do you want to find the midpoint sum, you want to explain this. Now this is a common question. If they don't ask you just to interpret an integral, they'll usually ask you to interpret an average value integral. So be on the lookout for that, because that's the case here. So first, if I'm finding this, again, I find it helpful to draw out the points, but I realize that's a little time consuming. But for some of you, that might be a good way to approach these problems too. So if you draw out the graph and then draw in your rectangles, that can help some people visualize what's going on. So you'll notice they tell us 3 subintervals, so that means 3 rectangles. So if I go from 0 to 6, and I have 3 rectangles, each one is going to be of width 2. So that's where all the 2's in the equation here come from. The 1/6 is from the problem, so I just have that 1/6 on the outside of the parentheses. And then the 5.3, 11.2, and 13.8 values, those are my midpoint y values. So for instance, the first rectangle goes from t equals 0 to t equals 2. The left Riemann sum would have me enter 0. The right Riemann sum would have me enter 8.8. But the midpoint Riemann sum has me enter 5.3. So 5.3, 11.2, and 13.8 come from the table because those are the middle y values for our rectangles. And again, if you draw out the rectangles, that might make a little more sense for some of you. So notice this is a non-calculator question. You are expected to be able to do simple decimals like this. So if you're out of practice like some of us are, feel free to do a couple of these questions before the AP exam so you've done it once or twice and you feel comfortable. So doing this by hand, we get about 10.1. Now notice I've used the approximation symbol. That's because a midpoint Riemann sum or any Riemann sum is approximating the integral. Finally, they asked us to explain that integral. So I want to say it's the average value, but I want to explain it in context. So it's the average y value. So what are my y's? Those are c of t, or ounces here. So I say the expression represents the average amount of coffee in the cup in ounces from t equals 0 to t equals 6 minutes. Now notice several things there in the steps. I want to mention the average. I want to mention what it's the average of, the coffee. I want to mention the units. It's the coffee in ounces. And I want to mention the time, from time 0 to time 6. Because in that integral, we're including all of those types of things. On the scoring for Part C, we're given 3 points. One for writing out the formula for the midpoint sum, meaning writing out all the parts of it, or saying I'm going to do 2 times C1 plus 2 times C3 plus 2 times C5. The second point is for actually doing the computation correctly, so getting 10.1 for your answer, 10.1 ounces. And the third point is for your interpretation. And again, in that interpretation, you really must include the word average, and ideally you're also including the time and the coffee as well, because those are all important elements. Okay, any one of those things missing could cause a loss of points here. On the last part, Part D, you're asked to use this model. And again, this is a pretty common technique. They'll have a question with data, and then the last part will say, well, let's use this model. So then it's getting at the fact that we're going to have to use some calculus on the equation as well. So here they give us the amount of coffee is really modeled by this function b of t. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. So that word rate should ring a bell. That means we're going to take a derivative here. So what they're seeing here is, can you find the derivative of this function? And can you plug in 5 to that derivative? So this is a chain rule question. So as we take the derivative here, we have an e to the x or e to the t function, but notice it's e to the negative 0.4t. So although the derivative of e to a power is itself, when we have that negative 0.4, we need to multiply that as well for the chain rule. So I get negative 16 times negative 0.4, which gets us positive here in that first line. And this is just b prime of t. Second line, I plug in 5 because that's the value at which I want the rate. So when we plug in 5, we get 6.4 e to the negative 2. Now again, notice this is not a calculator question, so it is perfectly okay to leave the answer like that. Okay, similarly, if you had pi in the answer or a square root that couldn't be simplified, like square root of 10, that would be okay to leave as the answer. On the non-calculator part, they don't expect you to do that by hand. Okay, leaving 6.4 e to the negative 2 is the expected answer. So finally, taking a look at part D scoring, 2 points there. 1 point for b prime of t, that general equation, finding the derivative of the b of t equation, and 1 point for plugging in 5 and getting the correct answer. So they're really testing both your understanding of the derivative, the chain rule, and then just your computation skills at the end.